Misfire. Misfire. Sounds like, Anyways, how y'all doing? We're talking misfires. What are misfires? Well, like everybody knows this, right? Not everybody does. Here, let's try it out. When incomplete or no combustion occurs in one or more cylinders due to improper fuel, ignition, compression, or air, something's upset a cylinder or all the cylinders. Now, this is not really a complete explanation. So here, anytime any fuel comes out of the cylinder, raw fuel, anytime any of it comes out, technically that's considered a misfire. It did not burn all of the fuel. Now, we've talked, and I'll talk again, but just due to construction of the engines, there's always going to be a small amount of residual fuel, raw fuel, exiting the cylinder. You almost can't get away from it. They have done much better in engine design and engine construction to be able to minimize it, although technically it's never completely gone. So that generally means that any cylinder event technically can be considered a misfire. The point I'm trying to make is, if I've got a complete dead cylinder, that's a misfire, and everybody knows that. But it's these partial misfires that sometimes you can't even feel them, okay? Sometimes they're pretty easy to feel. Sometimes the cylinder just isn't, a cylinder or a couple cylinders just aren't firing well. You know what I mean? They're still firing. So it's a level thing, if that makes sense. I mean, in one extreme we've got, a completely dead cylinder, no fire, no nothing. And then other times, the other end of the spectrum is we have just a little tiny bit of fuel coming out, which can be, that is considered a misfire. So it's a level thing. Okay, which the engine has to take this into account. Now, once the engine gets to the point where it's starting to damage the catalyst, well, that's a pretty severe misfire. What happens is raw fuel sometimes is getting into the cat and being lit off and burned inside the cat. So there's a secondary combustion event that happens inside the catalytic converter. If you've ever seen one, I've seen cars driving down the highway where the cat's glowing red underneath the car at night. Looks kind of cool, but that would be bad for the cat. So the computer has to let you know. This is where it gives you the blinky light. The best picture of a cat I could find. So it needs to detect this very quickly, usually from 200 to 1,000 RPM. But it's not RPM. It's R. It's 200 revolutions to 1,000 revolutions. I put RPM on there just so you guys know what I was talking about, but realize it's not revolutions per minute. It's how many revolutions the engine has gone through. Get it? We'll talk more about this later. So it'll set a DTC and then it'll flash the mill. Now, we'll talk about what misfire relief is in a minute, but just realize that it can be a type A or it can be a type B, and it may take some time for it to set this code. It may know about it, but the computer is probably going to go try to fix it. And it's going to fix it by trying to add or subtract timing or fuel into it, or whatever. The computer is going to try to solve this misfire before it becomes an issue. Get it? So when the cat damaging misfire is no longer there, the mill just stays unsteady. It stops blinking. So anytime you see a blinky mill, it's blinking at you. Usually not usually, but that's a cat damaging misfire. The car really shouldn't be driven at that point. You should pull over and call a tow truck. Either that or you're buying a very expensive cat because you're going to lunch it. All right. Emissions threatening misfire. This is a different level of misfire. Now, all this means is that it threatens emissions. Okay? 1.5 times its FTP. What does FTP stand for? Go back and watch the video if you don't know. So it has a much wider range that it has to detect it in. We'll talk about some of these detection strategies here in a second. So these are usually a B-type DTC. First trip arms it, sees the same thing pop up again, same type of misfire pop up again at the same speed, load, coolant temperature, happens again at the same spot, the same time, the same load and stuff. It'll pop a code for that. If it sees it past that, freeze frame, it will disarm the code. You get it? Anyway, sorry. Second consecutive trip. All right. So here's generally accepted what it's going to be: 375 RPM of the first time around, 20% of engine load, and the same coolant temperature. Now, when you start it up, especially if it's really, really cold out, I mean, a lot of cars below zero, they won't register a misfire. They just won't register one because it's really cold out, and you start the car up, it may miss a little bit, but the computer's not going to flag that as being an issue because it's really cold out. Also, the other place where misfires generally are blocked is low gas. I mean, if you're running out of gas, the computer pays attention to how much gas you have. And it knows if you're a cheapskate or not. And once the gas starts to run out, we get bubbles in the fuel that can cause a misfire. It will ignore those. Okay? There's also a couple other places we'll talk about in just a second. And then remember, this guy is stored for 80 trips. So this type B code can be ready and armed for, a month? Looking for the same thing. Anyways. All right, so here. One of the ways that we monitor misfire is we monitor crankshaft RPM. We monitor it in a very high resolution. So you can see on this particular graph that the crankshaft actually speeds up and slows down. And what this is, coming up on a compression, it slows down the cylinder, or it slows down the crankshaft because we're compressing a cylinder. And then when we fire that cylinder, RPM of the crankshaft speeds back up. So it's this kind of pulse that happens very, very quickly, and you don't even notice it unless something goes off the rails, such as a misfire. Okay, so here we have a dropout on the RPM, and it sees this and it flags this as being, hey, that's a problem. Now, if you ever seen a misfire code, P0301, P0302, P0303, that means, that gives you a cylinder ID. This is how they ID the cylinder, by looking at this. Oopsie, hang on. There it is. Okay, so this is an 8-cylinder engine, and you can see cylinder 7, if we count the humps, 1, 2, 3, 4, 5, 6, 7, 8, 1, 7, 8, 1, 2, 3, 4, 5, 6, 7, 6, 7. Now, it actually goes by firing order, okay? So if you wanted to look at this, you would have to write out the firing order on the humps. Get it? And then where do you start? Sometimes that could be a problem. Anyways, but this is how it's done. So it actually says, hey, I've got a problem with cylinder number 7. Get it? All right.